Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So today we'll be starting with our chapter number 9, which is momentum. So there are a couple of prerequisites. So let's quickly take a look at them. Number one, you should be able to solve linear equations. Okay, pretty simple, right? You need to just make the variable the subject of the formula and then get the value. Number two, you should be able to calculate the kinetic energy of a moving body. Okay, so let's say that if there's a particle of mass 3 kg and its speed is 4 meters per second. So the formula that we apply in order to calculate kinetic energy is half mv squared, and that's your mass, that's your velocity, so that will be 24 joules. Okay. Now, so what exactly do we mean by momentum? Now when we talk about momentum, it is the property of a moving object. Okay, that's the first thing. It is the quantity of motion of a moving body. Now if you want to understand what exactly, so here we have to look at two things, right? We need to understand momentum from two different perspectives. Number one, what do we mean by generally? Like, what does the word actually mean? Okay, and that's given here. Momentum is the property of an object that makes it harder to stop. Okay, so if let's say that there is a mass, okay, there's an object which is moving in a straight line. If it is difficult to stop that object, that means that that particular object has a high momentum. Okay. So that's the terminology that we use. So momentum basically depends on two factors. Okay, number one is the mass of the object, how heavy the mass is. If a mass is heavy, it is difficult to stop that object, so that means it has a high momentum. If an object is moving at a high speed, even if it has a low mass, but if it is moving at a high speed, even in that scenario it is difficult to stop that object. So therefore momentum is going to be high because of a high velocity or high speed. Okay, so let's see. In a basic sense, the more momentum a moving object has, the harder it is to stop. Momentum can be defined as mass in motion. All objects have mass, so if an object is moving, then it has momentum. That means that if let's say an object has zero velocity, if an object is at rest, but it is very heavy object, let's say if it's a truck, right, it still has no momentum because velocity is zero. All right, so similarly, if an object has no mass, right, which is quite a rare case, but if let's say it has a negligible mass, then no matter how fast that particle is moving, it does not have high momentum just because of its speed. So therefore, we can say that momentum is calculated by considering the mass of the object and the velocity of the or the speed of the object. Okay. All right, all objects have mass, so if an object is moving, then it has momentum, it has its mass in motion. The amount of momentum that an object has is dependent upon two variables. Okay, number one, how much stuff is moving, so that is the mass, right? And how fast the stuff is moving, so that's your speed. Momentum depends upon the variables mass and velocity. In terms of an equation, the momentum of an object is equal to the mass of the object times the velocity of the object. So momentum is the product of mass and velocity. The units of momentum are kilogram, meters per second. So kilogram comes from mass and meters per second comes from velocity. Or you can simplify it and write as Newton seconds. We know that a force is needed to change the velocity of an object. The force required to change the object's velocity is dependent on the mass of the object. So if let's say that you have two objects, okay, one is of 10 kg and one is of 20 kg. So definitely in order to move this box, okay, the box with 10 kg mass, is you're going to require a certain amount of force. But in order to move a 20 kg box, you need a higher force, right? So therefore it says the force required to change the object's velocity is dependent on the mass of the object. The precise relationship between force, mass, and velocity can be established by combining Newton's second law with one of the equations of motion for constant acceleration. Newton's second law was F is equal to ma, right? Where F is the resultant force, m is the mass of the object, and a is the acceleration of the object. And the equations of motion are what we covered in chapter number 2, where we had five different equations, right? So these equations were applicable in situations where the acceleration is constant. Now it says consider a force F Newton that acts for a time t seconds on a body. So let's say that this is our object, okay, and it has a mass of m kg, and you're applying it a force of F Newton in this direction. Initially, the velocity is u meters per second, and after applying the force, the final velocity is v meters per second. Okay, now the time taken to move the object from u to v, that was t seconds. Okay, so that's what's given here. So consider a constant force that acts for a time t seconds on a body of mass m kg in the body's direction of motion. The force causes the body's velocity to increase from u to v meters per second. As the force is constant, the acceleration it produces is also constant. Okay, so acceleration is constant, right? So that means that it's not increasing non-uniformly, but it's a uniform acceleration. So throughout this, you can say that throughout this journey, the acceleration will be a meters per second squared, which is constant. Now, if I need to work out the resultant force, okay, so I can use the equation F is equal to ma. So let's work that out here. So now, if let's say that I don't want to use a, rather I want to use, let's say if I don't know what a is, but I know what is the initial velocity, I know the final velocity, I know the time. So here we can use the equation v is equal to u plus at. So from here, we can make a the subject of the formula. That will be v minus u upon t. And you can substitute a with v minus u upon t into this equation. So we can say F is equal to m times v minus u upon t. Now this t can be multiplied to the other side. So you have ft, and here you have m times v minus u. If I further expand this, so we can get mv minus mu. All right, now what do we mean by that? We just saw that momentum is the product of mass and velocity. So here we have mass times final velocity, and here we have mass times initial velocity. Okay, so the right hand side part of this equation tells us the change in momentum. So momentum, if let's say it is represented by p, so we have p is equal to mv. This is a momentum of an object at a particular time, right? Okay, but if let's say that the velocity, sorry, at a particular velocity, the momentum at a particular velocity, but if the velocity changes, so now change in momentum will be final momentum, which is mv, minus initial momentum, which is mu. Here we can factorize m, so we can have m times v minus u for simplification. So this is the equation for change in momentum. So if you need to calculate that what change in momentum is, so for that purpose you can use this equation. And if you want to find out what the momentum is at one particular velocity, then you can directly use this equation. So that means that I can also write this down as this equation ft can also be written down as delta p. So delta p is equal to ft. All right, so now let's take a look at this. What do we mean by these equations? So here, this is how the equation has been derived. Now it says the quantity Ft is called the impulse of the force. For the purposes of the examination, knowledge and understanding of impulse is not required. So in our syllabus, the calculations related to impulse are not required. Okay, a basic understanding is a good thing. So Therefore, whatever we are going to study about impulse in this chapter, that will not be tested in the exam. All right, so let's make that clear first. Now, the right hand side of the above equation, mv minus mu, which is the change in the value of mass times velocity, this product of the mass and the velocity of a body is called its momentum. So momentum is equal to mv. Since momentum is a scalar multiple of velocity, which is a vector quantity. Now look, momentum depends on one of the vector quantities. So therefore, momentum should also be a vector quantity. All right, because it depends, because mass is a scalar quantity, but velocity is a vector quantity, right? So if one quantity is a vector, then that means that this quantity also becomes a vector quantity. So remember, vector quantity is the one where you have both magnitude and also direction. So if let's say the velocity, if only the direction of an object changes, that means its velocity changes. That means its momentum also changes. Okay, even though if the magnitude of the speed was 25 meters per second, for example, right? So that doesn't change, but what changes is the direction. Then it says that you need to consider only motion in one dimension, that is in a straight line. Okay, so basically the questions that you are usually given are in one dimension only. All right, the units used for momentum are those of ft. So that's how we got Newton seconds, right? So the unit for momentum can be Newton second, or they could be kilogram meters per second. Okay. A constant force acting for a given amount of time will change an object's momentum. When a force acts for a certain amount of time, then the impulse of the force is given by the equation. So this is your impulse, okay? The product force multiplied by time, right? That gives us the impulse. The units of impulse are Newton seconds, okay? Again, that same derivation is shown here. Impulse of a force. Now, although impulse and momentum, right, they basically have the same units, but they're not exactly the same. Okay, now let's understand this. Impulse of a force is the change in momentum of an object when a force acts on it over a period of time. So momentum is something that can be worked out of a moving object at that particular velocity. The impulse is the change in momentum when the velocity changes. When the object changes its velocity from v to u. From u to v, from the initial velocity to final velocity. So what was the change in momentum? That is equal to impulse. Impulse is not momentum itself, but an increase or decrease in momentum of an object. So that further clarifies what do we mean by impulse. All right, so let's take a look at example 1. A particle of mass 4 kg has an initial velocity of 5 meters per second. Find the momentum of the particle. Okay, so we know that momentum is equal to mass times velocity. So when the mass has this velocity at that particular instant, it has the momentum equals 4 times 5, which is 20 Newton seconds. The magnitude of the change in momentum if the velocity of the particle increases to 12 meters per second. So change in momentum is equal to final momentum minus initial momentum, right? So you can factorize m. So we can now say m is 4 times final velocity is 12, initial velocity was 5, so you can say 4 times 7, which is equal to 28 Newton seconds, right? So this is a much efficient way of working, but if you want, you can also work them out separately. You can separately work out what the final momentum is. So the final momentum will be mass times velocity, which is 12. That will be 48 Newton seconds. And then you can work out the change in momentum later on. Okay, or you can directly write it in this form. Okay, so here we have change in momentum, m times v minus u, and exactly the same process that I showed earlier. Example 2 is a particle of mass 2.5 kg has an initial velocity of 3 meters per second, mass is 2.5 kg. Find the magnitude of the change in momentum of the particle if the final speed of the particle is 5 meters per second with the direction of motion unchanged. So let's say that this is our object whose mass is 2.5 kg. Okay, and initial velocity was 3 meters per second, and it was moving in this direction. After some time, the final velocity is in the same direction, so that is 5 meters per second. And now you need to find out what is the change in momentum. So again, we can say change in momentum is equal to m times v minus u. So that will be 2.5 times 5, which is final velocity minus initial velocity. So 5 minus 3 will be 2, and 2 times 2.5, that will be 5 Newton seconds. Okay, so that's part A. Or if you want, you can work them out separately. That's up to you. So you can work out initial momentum, so that will be 7.5. You can work out final momentum, that will be 2.5 times 5, which is 12.5, and the difference will give you the change in momentum. Now the question is, find the magnitude of the change in momentum of the particle if the final speed of the particle is 5 meters per second, but the direction of motion is reversed. Okay, now understand this. Because momentum is a vector quantity, if the direction has been reversed, so we were taking right hand side to be positive, right? So if in the second scenario the direction has been reversed, so that means the velocity is going to be minus 5 meters per second. Okay, now if you're to work out the change in momentum, so that will be again m times v minus u. So that will be, our mass is 2.5, velocity is minus 5, and initial velocity is minus 3. So that will be 2.5 times minus 8. So let me work that out. 2.5 times minus 8, so that will be minus 20 Newton seconds. Okay, all right. Okay, let me check this. The final speed is 5 with the direction of motion reversed. Okay, so minus 12.5 minus 7.5. Right, so there's a this is incorrect. Okay, because minus 12.5 minus 7.5, that will give us minus 20. So let me correct it over here. So because they asked you about the magnitude, right? So we do not give minus sign. We will only say 20 Newton seconds. All right. Okay. So I hope that this concept is clear. This is the end of our lecture number 1. So I'll see you in the next video with lecture number 2.